So then again, I'm still Olivier Lecompte. I'm a PhD student in mechanical engineering at Polytechnique Montréal, where I have the opportunity to work on the development of a stimulation device to give back the sense of touch to upper limb prosthesis users. So upper extremity prosthesis have seen significant technological advances in the recent years, primarily with the advent of things like myoelectric prosthesis and other designs incorporating robotic elements. Users now have a way to communicate their movement intent to the prosthesis. However, the lack of physiological feedback prevents the proper integration of the prosthesis and generally leads to the rejection of the technology. So the literature on artificial sense of touch primarily discusses strategies to emulate tactile perception, which is like the pressure you feel on your fingers. But few address the proprioceptive perception, which is mostly like the configuration of your limbs in space. Even though it has been shown to be a crucial element in object manipulation. So the main objective of this project is to achieve optimal proprioception sensory feedback restoration. The term optimals refers to a sensory restoration device that is characterized as being non-invasive, somatotopic, and in real time. So therefore, the signal will evoke sensations that match the original location, whilst involving no perceptible delays. The project follows the typical biological architecture involved in human perception, and my work will mostly cover the decoding, encoding, and actuating phases. To do so, we envision to use a robotic hand for the development. A microcontroller will act as an interface for their sensors and the actuators, and a ROS architecture will be implemented on an embedded computer to provide the encoding portion of the project. Finally, transcutaneous electrodes will be used to provide non-invasive transduction. It's expected that this project will help provide an optimal proprioceptive feedback to the user, which will facilitate user adaptation of the prosthesis, maximize their confidence in the prosthesis, minimize the adaptation period, and minimize the cognitive effort required by the user. Thank you.